Whew. Hello. How we doing? Doing good? My mother doesn't know what I do, so this isn't going to help her, but if everyone can just yell "yeah" as I come around, okay? Yeah! Mom, I don't know. That was fun. So look, yeah, my name is Ben Schwartz. I'm from Melbourne, Australia. And as Carolina mentioned, I've been coming here for a few years, and it's my favorite conference anywhere in the world to come. So to be able to come and speak is actually a really huge privilege. So thank you to everyone for making it great for me to be here. My talk today is called Beyond the Bubble. And what I hope to achieve is to give you some context that maybe you haven't maybe necessarily considered, as part of your day jobs. When we usually talk about performance, we talk about how quickly pages load, we talk about how much money Amazon made when they made something half a second faster, but often that's kind of really as far as we go, which I think is really sad because performance is a pillar of user experience, and yet every aspect of performance work that we're doing right now seems to be a bit of an afterthought. Sites are often deployed to production, and then we say, all right, let's see how this performs. And if the results are disappointing, then maybe we then go and do our best to see what we can do. But often we have to just move on because there isn't the time, there isn't the budget, and nobody's really sort of committed to it by that point. And worse still, when we're doing this with, when we're building these sites and apps and these experiences, we're doing it using a $3,000 computer or a $1,000 phone, and you're doing it on localhost. And of course it's going to be fast. So I think it's our job to understand that context a little bit better, and so hopefully we'll get there today. I'm the founder of a company called Calibre. It's a reasonably young company. It's so young, in fact, that I'm the solo co-founder. I'm the only person in the company. I do everything. And what that really means, I'm full-time now. I became full-time in January. And ultimately, that means that every day I'm helping to build tools to make the web faster, or helping to try to contribute to that. Or I'm doing audits for people, or I'm diving into stack traces. And I'm kind of just doing that performance work that you would maybe do if you had the time, but that's all I'm doing right now. So I hope through that you'll maybe enjoy the talk ahead. So I thought it would be really interesting to look at somewhere where time really equaled money. And in the last 30 years, we've been trying to reduce latency between locations, but somewhere where it was really sort of hyper-focused was in the stock exchanges between Chicago and New York. And every few milliseconds that you save literally billions, or you make literally billions of dollars. And in the mid-1980s, the round-trip latency was about 14.5 milliseconds. And this was cut by a millisecond and a half in 2010 by they shortened the physical fiber route that it actually took. But in 2012, they thought, hey, this is too slow, so we're going to try and do something else. And if you look in this cow field somewhere between New York and Chicago, you'll see that large tower there, and that's actually a microwave tower. And these towers we're using these towers, they're actually able to get that connection speed right down to like 4.2 to 5.2 milliseconds, which is, as you can see, a huge improvement, 3x over where we sort of started back in the 80s. Interestingly enough, these towers were, when they were constructed, they were buying up little plots of farmland in between, and I think some of these towers they actually had to pay these farmers $500, in the regions of $500 million to just put a tower there. And I think that's particularly interesting because I think when we're building sites and apps and we're throwing them in a browser and we're delivering this HTML, right? And as you saw in Addy's talk, now we're getting a little bit better at detecting the resources that are in the page and then pre-getting them. But up until now, what we've been doing is this. we're just throwing things down at the customer, and we're just saying, just take it all. I don't care about you. But whether on a tiny phone with a really slow CPU, or maybe you've used all your data plan like I have here in Berlin already in a week, we're not really doing enough here. So I'm going to take you through some stats about the state of global connectivity, and yeah. Okay, so right now there are 7.4 billion people on the planet. 46% of them have access to the internet, which means that we're actually at a point where there's 4 billion people who don't have any access to the internet at all. We're only halfway there. We're not even halfway there yet. So why don't we have a look at how quickly the internet is growing? And if you were thinking, well, maybe Europe is getting better connectivity, maybe it's US, there's 300 million people there. Maybe it's in Australia, where I'm from, and we're really trying to build a faster internet, but struggling. It isn't really sort of in that bubble that we're in right now today. If you look at India, just last year, their internet users grew by 108 million people, which, in case you were wondering and you haven't checked Google recently, that's more than the population of Germany. And this is 30% year on year from the year previously. If those numbers are matched again this year, that'll be 140 million people. Airtel, who are the largest carrier, have 255 million customers. This is just people who have a phone plan. And this stat has actually, last time I researched this stat, it's gone up by 5 million subscribers. And their share has actually fallen from 32% of the marketplace. Truly, truly incredible numbers. But in India, only 65% of the 1.2 billion 65% of the 1.2 billion don't have access to the internet. So that means that's 864 million people who are yet to get the internet. And they're about to. And that's essentially the population of China again. I took some time to look at what data costs in different locations. And so the way that I came up with these numbers here is I took a prepaid plan, which is usually cheaper than a postpaid plan, and I took the minimum wage of these countries, and I calculated how many hours would you have to work just to get 500 megs of data. In India, as you can see, it's 17 hours, but in Germany, it's actually less than 1 hour. So our, let's call it data addiction, isn't quite met with the same enthusiasm in other places in the world. Could I get some water up here? That could be 1 hour for 8 songs on Spotify, 6 minutes of YouTube, and less than an hour playing games. Thank you. Or, which I think a much more fun stat, you could go to The Verge, empty your cache, and hit reload 38 times. But even if you can afford the internet, you're not necessarily going to get fast internet all the time. Back in Melbourne last year, I lived on the wrong side of the street to get cable connection, so I ended up having DSL, and it was a lot slower than it should have been. Even if you have LTE advertised on your phone, you may not get the same LTE speeds. In Singapore, the average is capping out at about 50 megasecond, which is actually super, super great. But if you look down at India, it's just doing 6.39 mbit a second. So it's very different no matter where you are in the world. I had a look at German internet plans, because I'm Australian, and it's very different here. And I saw that there were 400 mbit connections available. This was about, I found a plan that over the period of a year worked out to about 30 euros a month with a contract and everything like that. But you could get a 400 mbit connection to your house. So putting that on a global scale, does anyone want to guess where the global average for connection speed would be? Just shout out numbers. 2? One guy. One guy has an answer? There's 800 people. 50. 50, OK. It's actually 7. This is the global average. So this is, it's pulled down by some places and pulled up by others. I thought maybe we could look at the mobile speed. In Canada, which is covering the Americas region, the best average, or the highest average speed is 10.3. In Australia, for Asia Pacific, it's 13. For United Kingdom, Europe, it was 26.8. And the UAE, for the Middle East Africa region, was 17.2. But it goes further than that. 60% of all global mobile connections are actually 2G. So we know that even if you do have LTE, you can't really assume it's going to be fast. And on average, we're only doing 7 Mbit a second. Let's have a quick look at devices. Most devices on the web are handsets. This has been the case since 2014. And I thought maybe I would have a look. I have an iPhone in my pocket, and I'm sure a lot of you do too, and maybe use an Android, and that's cool too. Have you ever thought about the devices that people use in other locations? I had a look. Here are the top 5 devices for three regions. China had 3 phones that I had never heard of, and they were selling they were selling enough devices to cover the population of my country multiple times over a year. So that's reasonably significant. The I don't know hands in India is corresponding to the it's a very mixed market, but it's a big collection of devices. So I got to wondering, is there a single device that best represents average for us to go? Like, if we need to, we know that all these devices are super, super different. How do we test this, and how do we understand what to do next? Thanks to our friends at Google, there has been some research done into this. At the moment, today, if you were to take a fairly average phone, it's not super expensive. I think in Germany it's 180 euros. If you were to go and buy one, you'd end up with a quad-core CPU, 2 gigs of RAM, decent amount of storage. Now, this isn't the slow phone that people in performance talks like mine will tell you is you have to think about these other people. This is a pretty middle of the road phone. It's not the fastest, it's not the slowest, but if you average out global devices, this is where you'll end up. And that's really great because you can test this on web page test any day of the week, and they have these actual devices sitting in data centers around the world. So that's really great. But let's just say that you didn't have access to a device. Here's what you can do. Go into your Chrome DevTools. It's going to play. OK, go into your Chrome DevTools, click on the timeline, click on capture settings, go to CPU, drag it down to 5. Now, I know 5 is seemingly an abstract number, but if you're on a recent MacBook Pro, you're going to end up with about the speed of a Moto G4. There's been some research put into this, and obviously you can try and calibrate your device and check the JavaScript performance, but if you're looking for a kind of close enough experience, that's where you should end up. So it's a 5x slowdown. But what's clear after we've looked at a little bit of connectivity and a little bit of devices is that there aren't really any contexts. If you go for a proper average, it changes daily. I like to think that there are 2 versions of the internet. There's the one that we use, us, and then there's the one that we usually don't. And I've been experiencing a little bit of the column B in the last couple of weeks here in Germany, and the airplane Wi-Fi, I think at times was actually better than the Airbnb Wi-Fi that I have at the moment. The conference Wi-Fi hasn't been too bad. Thank you for doing really well on that JSConf. And then there's Li-Fi. Li-Fi is when your device says that it's on Wi-Fi, but nothing happens. And we know that the connections vary, and we know that it might be just because you're at the wrong end of the building and there's too many brick walls for the Wi-Fi, or a conference, or a plane, or a tunnel, or just for whatever fucking reason, your modem needs restarting again. It happens, I understand. One thing is clear. We need to stop optimizing for $3,000 computers with fast connections. Devices, connections, language, context, they're different for everyone. Inconsistency is a major property of the web in general. But now that we're understanding that we're in a global landscape, it's time that we start thinking about strategies to better scale what we're delivering to people. So we should gather some knowledge and build with more understanding and more empathy. Looking a little bit beyond the delivery of an asset, or looking at how an asset is put down onto a device, we're generally looking at three things. Delivery. So this is the time where we're saying, how many scripts are there on this page? How big are they? What do they look like? Is there a lot of JPEGs? OK, cool. There's the pass cycle. So this is when the browser gets those assets, and it has to figure something out. Maybe it has to decompress the gzip on a resource. Maybe it has to parse and compile the JavaScript. Maybe it has to get an image and composite it before it actually paints it. And the last part of that is runtime. These three phases of sort of performance that we should worry about. And runtime is obviously the actual runtime that we're giving smooth, fluid animations, and we're making it responsive to user input. But unfortunately, at the moment, the one that we're really forgetting is this pass time. We're throwing down these scripts at the browser, and we're just hoping for the best. This wonderful graphic is taken from Adi Osmani's brilliant blog post called JavaScript Startup Time. And it's a rough kind of how V8 works, or more like, as far as the V8 people tell me, how it will work really soon. And this varies from engine to engine. But they take your JS, they parse it, they turn it into an AST, they generate bytecode, they do some optimization stuff, and then they build it for your architecture. But when you're taking the 410 average script size, this is the average across the web, right? This is what we're on average sending. There has been the argument that maybe we can just reduce that size. Maybe we can just remove a JPEG. I won't name names, but this became a bit of a popular thing to say a couple of years ago. But I'll tell you why it's wrong. Forget 410 KB. It's not 410 KB. Because when you decompress it, it could be 3 to 4 megabytes. And it's 3 to 4 megabytes that your phone has to go and understand, compile, and deliver something. I took the JSConf EU site, which is actually really light. Whoever worked on it didn't have to do a lot of stuff to make a pretty website that told you everything about the conference. It only had 57 KB of script. And that's jQuery, some web stats, and a tiny 1 kilobyte app.js. And as far as I can tell, all it was for navigation. So nothing really sort of sinister going on there. But when I benchmarked it on a desktop, this one, and a Moto G4, I found that the script time, all I'm doing is loading the page. And as you can see, we're spending 3 times the amount of time just in scripting. And why is that important? Well, it's important because this is happening in the JavaScript main thread. And this is also blocking paint. And these are all the little things that make your website feel, when you're also contending with web fonts loading, and they're loading, and then appearing, and then disappearing, and then a different one appears. And then your user is scrolling, and it's janking, and then an image loads, and then that pops back up. You've all seen it, right? We're all suspect to it. I do it. I took a real site, Lufthansa. This is the mobile site. So this is probably reasonably optimized. On average, a little bit bigger than other stuff. And it actually compressed really, really well. And again, well, it was double. It doesn't mean that these numbers are completely linear. You can't say that it's going to be 600 KB and that's going to equal these many seconds. You do need to test this stuff. I did start doing some testing, and I thought, well, let's do an experiment here. I mean, we're at at a JavaScript conference. Maybe I can just say, delete all of your JavaScript. And you might not like that. So I took the Guardian's website. The Guardian have done some fantastic work. Patrick Hammond, who's here, spoke 2 years ago at CSSConf. And he showed all the really great work he's done at the Guardian. And so I don't want to bash it up too much, but I'm going to show you something. This is the Guardian loading side by side. On the left, we have it without JavaScript, and on the right, we have it with. If you didn't see, the version on the left, was completely visible in under 5 seconds on a 3G connection. Bang, done. The other side, well, there's the fonts switching, loading. The weather appeared, and then a related article appeared at the bottom of the screen, and it stopped rendering somewhere around the 22-second mark. And unfortunately, the 22-second mark is about the average. The average for this is about 17 seconds. So this is not a bad website. This is very, very normal. It goes a little bit further, too. Of all of the requests that were, the difference between the requests, and it wasn't all JavaScript, it was images and assets and other stuff. With JavaScript, it was 3.4 megabytes, 115 requests, and otherwise 1.59 and 61 requests. And I think that's a lot to just show people a related article and weather and different fonts. I don't know about you, but we offered the same experience, but we didn't really improve it. And we talk about progressive enhancement for so long, and yet we're doing this every day. One thing that I've really noticed in my time of trying to optimize websites and trying to build a product that optimizes websites is that the metrics that we're currently using really don't tell us much about the people. And I think they're the important part. For a while, we've used metrics like onload, on DOM content loaded, which is kind of your everything's ready, DOM ready, and speed index, which is my particular favorite to have a little go at. There's a problem with speed index, and it doesn't mean anything to real humans trying to understand the metrics either. Have you ever tried to explain this to your PM? I have. I know people who put MS after it so that it looks like seconds. Good metrics can't be gamed, they aren't at risk of failure, and they aim to try to explain something. Here are some examples of some good metrics. First paint, visually complete, and time to interactive. Has anyone heard of these? Any of them? All of them? Some of you? Okay, cool. I'm going to explain a little bit about what they are. So your user navigates. We have a first paint, and a first paint is just when the user sees anything that isn't a white screen. We go on, we render a little bit more, we have the first contentful paint, and then we have some more graphics starting to appear. The fonts still haven't loaded yet. And then we get to a point where we get the meaningful paint, and that means that the text is visible. Somebody can actually see something that means something reasonable. And of course, visually complete is just when the area in the viewport is fully resolved, let's call it. That's great. These are human-centric metrics. Now, visually complete is a bit of a difficult one because it's not really something that you just do get out of DevTools. So how can we produce these metrics and actually get something out of it? Thankfully, there's a tool called Lighthouse. It's built by the Google Chrome team, and it's really fantastic. It comes as a browser extension, and you can just go to a website, click on it, generate a report. It loads your site by default in a Nexus 5X, I think. And it slows the CPU down. It checks it in an offline mode. It'll give you some stats about how it's performing as a progressive web app. Does it have a service worker? Does it have what does the critical request chain look like? Performance and some accessibility stuff and best practices. And that's really great. I have a little secret though. You're gonna, can we just keep this just between us? Okay. As of Thursday, Lighthouse actually dropped into Google Canary, Google Chrome Canary, and I'm going to show you how to actually go and get this now. So you need the latest Chrome Canary, and you will animate, I imagine. Yes. Okay. You need to go to the Chrome flags page, search for DevTools experiments, turn that on. Then relaunch your browser. This is quite a step, isn't it? Go to the thing that you want to, and then pop up your DevTools. Go to the settings down here. Over to the experiments. You don't see it, right? See how it appeared? You have to press Shift. It's a little secret. And then they appear all those things that you didn't know were there. Then you have to turn it on, close it, open it again, and audits 2 will appear. After you've done that, you'll get a little Lighthouse button, and you can perform an audit. And you can choose the audits that you want to do, and you'll get some idea of the performance of your browser. I'm not sure when this is going to reach stable, but they're working really hard on it. Google I/Os in a week and a half, and the guys have been working really, really hard. So that's really cool. We know what first paint, first contentful paint, first meaningful paint, visually complete all are. I'm going to talk to you about what this other metric that we've heard a little bit about is. It's called time to visually complete. And this is how they're calculating it now in Lighthouse. And I think it's really, really cool. So we watch the timeline, and we figure out when the browser, is visually complete. And then we're watching the JavaScript main thread. And we're watching these little subtasks that are happening, and we're looking for ones that are shorter than 50 milliseconds. And we figure out when there's a 5-second window without a long task, and then we call that first interactive. So it's after it's fully rendered and when the JavaScript main thread has stopped working. And the reason that we do that is because time to interactive is a really good way of getting that empathy for a user that it's not popping around the web fonts anymore, and it's not jumping up and down, and it's not going all over the place. So your target for every device, and I'm talking about the Moto G4, I'm talking about all those phones in your pockets, do it in under 5 seconds. Or even better, maybe we can actually come up with some things like the Twitter team do. They have a metric that they call time to first tweet. They've been using this for years. Try and find ways of understanding how your users are using your apps and sites, and get a metric and track it. Because it doesn't matter when onload happens. That's totally irrelevant. Don't try and keep people on your site for as long as possible. Help them get to their goals and do it quickly, and so they can go and do something else that's far better. And I know that the performance landscape is really vast, and there's so many bits and pieces to worry about. My advice to you is to pick 1 or 2 of them and give them a shot. And all of these things that are on the screen here, using a CDN, modern image formats like WebP, the purple pattern, all of these will improve website performance. So give one of them a go. Test it, measure it, and improve. If you're wondering where I got any of these stats from, they're from the Akamai State of the Internet report. Has anyone seen this before? Like 10 people, I think. OK, so it's a quarterly report that Akamai put out. So all my data is from Q4 2016. And it's just a PDF report. You can send it around with your team, and you'll see what all the global averages are. The global average for connection speed went from 6.2 Mbit per second to the 7. So we are actually slowly improving, but it's very slow. And remember, we've been so focused on the wealthy Western web for so long. We're just building for the machines that we're using. But that's bullshit. We didn't sign up for that. We signed up to build the World Wide Web. I really want to encourage you to try and make the web fast for everyone. That's what I'm trying to do at Calibre, and that's what I'm dedicating all of my work to at the moment. So, hopefully you can give Calibre a shot. If you don't, use Lighthouse, because that's great. If you otherwise want some stickers or something, come and see me. I'll hook you up. It'll be cool. Thanks a lot.